this video, we will discuss about the designing aspects of climate-responsive buildings in the tropics. It involves basically two key strategies. I shall discuss the strategy to minimize the heat ingress into the building, and my colleague will discuss the strategy to maximize heat dissipation from the building. As far as minimizing heat ingress is concerned, we shall consider building orientation, sun protection, keeping the surrounding cool, etc. Also, we shall keep in mind that the local conditions may differ substantially from prevailing climate of a region, depending on the topography, altitude, and the surrounding, which may be either natural or built by humans. The site condition should be considered in designing the details. In general, elevated sites are preferable, and buildings should be placed near large bodies of water such as lakes, and preferably on the leeward side, since they have a balancing effect on the temperature in the adjacent areas due to the great thermal storage capacity of the water. In a densely built environment, temperature rises, wind velocity and its ventilation effects are generally decreased, but channeling effect of streets can cause the opposite to occur. The usually porous tropical building scheme mandates that the outdoor comfort be simultaneously considered along with the indoor comfort. In this regard, green surrounding is desirable. It provides shade, lowers the temperature, improves the air quality, and reduces the effect of strong solar radiation on the walls of buildings and structures. It also protects the walls from heavy winds and rains. The surface to volume ratio is an important parameter. Smaller ratio is suitable for regions with hot-dry climate, as it reduces heat exchange between the building and the environment. A compact building gains less heat during the daytime and loses less heat at night. North or south-facing orientation reduces radiation to a minimum during hot periods. East and west-facing walls receive the highest intensities of radiation, thus these facades should be kept small and contain as few and small openings as possible. Simple sunpad software or SketchUp can be used to determine the optimum orientation. Place important rooms strategically to benefit from climatic advantages. For instance, locate a bedroom preferably on the eastern side where it is relatively cool in the evening, or place the living room on the northern or southern sides depending on the geographical locations. Locate heat, humidity, or odor producing spaces such as bathroom, laundry rooms on the lee side of the building. Shades can be provided by the shape of the building itself, for instance by cantilevered upper floors or arcades. It is important to consider balcony, veranda, corridor, or surface areas such as kitchen and bathroom as thermal buffer zones for primary spaces such as living room and bedroom, particularly those in east or west facing orientation. A common means of shading is the use of appropriate devices placed outside the facades. The sunspot is the main criterion for their designs. The shading effects depends not only on the geometrical shape and orientation of the fixtures, but also on the material used and on the surface treatment and color. Movable exterior shading devices provide better indoor thermal environments. Thermal insulation reduces daytime excessive heat entering a building, but it prevents the building from cooling down at night, unless night ventilation is effectively deployed. Wall and roof surfaces with high reflectivity of the order of 0.84 are preferable, while retaining emissivity close to black body or around 0.9. Such surfaces would absorb less heat and at the same time emit better the stored heat to the environment and the sky at night time.